This is the 11th lecture in the Fiber Optic Association series on fiber optics. This lecture covers fiber optic network design, part 3, choosing components for the fiber optic link. For every fiber optic design project, there are a series of components that we have to choose appropriate for the application. This includes the fiber that transmits the signals and the cables that protect the fibers in the environment in which it's installed. The connectors, which join the fibers temporarily or connect them to communications equipment, and splices, which join the fibers permanently. Then there's all the hardware that we need to protect the cables, splices, hardware of various sorts in the application that we're going to be doing the installation. While we often think of fibers as either single mode or multi-mode, there's a lot more choice than that. For example, in single mode fiber, typical for outside plant, you can use standard single mode fiber, which you'd use in a metropolitan network, unless of course you wanted to do coarse wavelength division multiplexing, and you'd use a low water peak fiber. Longer lengths would use cutoff shifted fiber or dispersion shifted fiber, especially if you're going to be dealing with dense wavelength division multiplexing. For gigabit networks running on multi-mode fiber, you basically would choose one fiber, FDDI grade. But now there's a number of special application fibers for higher and higher bandwidth that require you make a choice among OM2, OM3, and OM4. It's all a matter of how far and how fast your network needs to transmit. In a premises application, we'll generally install the best multi-mode fiber that fits our budget, like an OM3 or OM4 laser optimized fiber. We always include lots of spare fibers. Fiber is cheap. Installing cable is expensive. So if we think we're going to expand the network in the future, we always do, we always include lots of spare fibers. We sometimes put single-mode fibers with their virtually infinite bandwidth in multi-mode cable. We call it a hybrid cable. We sometimes include fibers and copper conductors in the same cable. We call those a composite cable, and we can use them, for example, to bring power to a remote antenna, but the signal goes out on fiber. One of the things we try to do is avoid mixing incompatible fibers, like 5125 and 62.5 125 in one cable plant. In choosing a cable, the primary thing we have to look for is a cable appropriate to the application, whether it's a premises cable that's flame retardant or an outside plant cable that resists moisture and rodent penetration. There are lots of different categories of cable that we have to consider, and we want to make sure it's proper for the job. We want to make sure that the cable includes enough fiber for redundancy and future upgrades. It has to meet all the environmental specifications that the cable is going to be installed in. It has to fit the budget. And then, once we choose the cable, we choose the cable hardware to fit the cable type. For outside plant cable, the fiber is mostly single mode, although there is some multi-mode used in, for example, utility applications and transformer substations. The outdoor cable is typically a loose tube cable. It may be direct buried if it's armored, or it can be run aerially. There's even optical power ground wire, where utilities actually run the fiber inside of a conductor of their high voltage network. As we always say, the cable must meet the environmental requirements of the installation. Each type of outside plant cable has its own characteristics. The loose tube cable gives us the ability to withstand higher pulling tension, and it's easy to water block. Ribbon cable has a higher fiber count per diameter of the cable. Water blocking is now done more by dry powder than by gel, and always we armor cables for direct burial to prevent crushing loads from harming the fibers and rodents from chewing through the cable. For aerial cable, there's lots of choice. There's cables lashed to messengers, figure 8 cable, optical power, ground wire, and all dielectric self-supporting cable. And once we go underwater, there are lots of special underwater cables depending on where they're going to be installed. For premises cabling, with the exception of telco central offices, most of the cabling is multi-mode, with some single mode for backbones and local area networks. We often recommend installing hybrid backbone cables, some multi-mode, some single mode, so that you have both fibers available. The single mode is good for future high bandwidth applications. There are 4 basic types of cable we use indoors: simplex, zip cord, distribution, and breakout. Zip cord cable or simplex cable is used mainly for patch cords, although zip cord can be used for connections to the desktop or to things like video cameras. Distribution cable is used for longer backbones or where you need many fibers. Breakout cable is a rugged cable type that's used primarily for short backbones and industrial applications. Blown-in fiber is an option, and we'll talk about that too. Armored cable is even used indoors sometimes, particularly for underfloors in data centers or in trays with many copper cables that may put pressure on the fiber and cause damage. All premises cables must carry identification and ratings. In the United States, it's per the National Electric Code, or in Canada, the CEC. Cables without marking should never be installed indoors, as they will not pass inspection. And of course, since they may be flammable, they're not safe. Here's a listing of all the ratings for indoor cables, and you have to choose a cable that's for general purpose, that's rarely used, riser, which is a higher rating for flame retardants, or plenum, which is used in air handling areas overhead. In Europe, cables are often labeled for low smoke density, which means these cables, when they get hot, don't burn and don't emit toxic vapors. Connectors are generally chosen to fit the equipment, the communications equipment you're connecting to, or to match the connectors in the current cables that are already installed in a building. At the current time, the most popular connections are STs, SCs, and LCs. If you have a cable plant with different connectors than the equipment that you're using, you can use hybrid patch cords. For example, an LC connector to connect up to a gigabit switch, to an SC connector on the other end to connect to the current cable plant. The termination type, adhesive polish, pre-polished splice, is at the customer option. And single mode, of course, like the outside plant, is usually terminated by fusion spliced pigtails. Here's the 3 most popular fiber optic connectors: the ST at the top, the SC in the middle, and the LC at the bottom. In multi-mode, we generally terminate these connectors in the field, but in single mode, we'll splice on factory-made pigtails. Although in either case, you can use pre-polished spliced connectors. You no longer have to terminate in the field at all if you design a prefabricated cabling system. Generally today, they'll use multi-fiber connectors inside pulling boots, so you pull the backbone cable and connect it up to modular breakouts into individual connectors at the patch panel. When it comes to splicing, you generally choose the splice type according to how many you're going to make. If you're doing a large number of splices, a fusion splice will be the least expensive, and it will also give you the lowest loss and reflectance and the highest reliability. But if you're only doing a few connections, a mechanical splice will be less expensive. Choosing hardware for the installation is the most complicated part because there are so many options. Cables are generally installed in conduit or in cable trays or suspended from hooks, like you see with these large masses of single-mode fiber in a central office here. Terminations can be stored in wall-mounted boxes, as we see with the small fiber count cable at the top picture, or for large numbers of connections, we'll use rack-mounted patch panels that are often in the same rack as the communications equipment, as we see in the bottom. Splices are stored in splice trays to protect them and the fibers they connect. Each tray generally stores 12 to 24 splices, and those are then placed in racks or in outside plant closures. Splice trays go in splice closures like the small one used for 2 cables being terminated as part of a traffic control system. Larger ones can hold hundreds of splices. All splice closures are completely sealed to protect the fibers and the splices from the environment, but most are designed to be re-entered in case of maintenance. We're the Fiber Optic Association, the professional society of fiber optics. Much more information on choosing components for your fiber optic network are on the FOA website on the online reference guide to fiber optics.